Greetings, welcome to the Transforming Assessment webinars. Today is 5th of September. Today's session is a virtual work integrated learning in engineering, and our speaker today is Associate Professor Sally Male from the University of Western Australia. So Sally, would you like to begin please?
Good morning, good afternoon, good evening. Thank you very much, Matthew, for inviting me to speak about the Virtual Work Integrated Learning project. I am leading this project, but it's a national project involving lots of people. I'd like to start by explaining the painting that I used as a logo for the project. When we first proposed it, the project, that is, people thought it was about students sitting in front of computers, and it's not. It's actually about students working with people from over the hills and far away, engineers from across the country, and even hopefully eventually students from across the country as well. And they might be connecting electronically, but it's about all these people coming together to support students to develop the employability skills that they need for working as engineers. So that's the reason for the painting that you see on the first slide. We have a grant from the Australian Government Department of Education and Training, and other partners are the universities whose logos you can see on this slide, and importantly Engineers Australia, who has, among other things, an important role in supporting us to align the program with the accreditation of engineering programs in Australia, and also supporting us to have volunteer professional engineers to work as mentors with students in this project, and the Australian Council of Engineering Deans, which of course is instrumental to adoption of the project and possible testing that we're doing during the project. And there's one other organisation here that's a partner but not one of the Australian universities, and that's Single View International, which is a learning technology company. Now, these are the things I would like to speak about today. First, I will introduce Work Integrated Learning in Australia and its assessment in engineering in Australia, referring generally to Work Integrated Learning in engineering in Australia, and also specifically to some findings from two projects that I will introduce. And then item 2 on the list here is to identify for you the problems with traditional Work Integrated Learning in engineering, and item 3, how this project, the Virtual Work Integrated Learning project, will address those problems. How we plan for it to address those problems. And then item 4 is moving into the specifics about the project. In particular, if we think of it as a design project, it is about exploring non-placement work integrated learning by developing collections of learning activities, related learning activities that we're calling modules, and exploring their feasibility and efficacy, both for the learning that comes from that and also hoping that the modules will be adapted as well and used broadly. So if we think of it as a design project, there are design requirements, and these include the learning outcomes of the modules, how they will be assessed, and other requirements as well, which I will speak about at item 4. Number 5 is an outline of the modules that we are working on, and items 6 and 7 will be focusing on 2 particular modules. One is a simulated workplace scenario for students to learn about self-management in the workplace, and the second, item 7, is using virtual reality to teach safety and design. Finally, I'll make some concluding comments and some important acknowledgements, and there will be time for a conversation, including as much as me responding to your questions, your comments, and your experiences as well. So I look forward to that. Now, the first thing I want to speak about is a broad introduction to Work Integrated Learning and its assessment in engineering in Australia. Engineering programs, I'm talking about engineering programs for professional engineering, leading to professional engineering status. Most of those programs in Australia are accredited by Engineers Australia, which is a signatory to the Washington Accord, meaning that this recognition is recognised in many other countries around the world. And that accreditation process is basically a check that as the accrediting body is confident that graduates, I might turn the graduates of engineering programs of the accredited program over the next period until the next accreditation visit meet the stage 1 competency requirements. These are knowledge and skills, ability and personal attributes that engineering graduates of accredited programs should have. Importantly, it is an outcomes-based system, but Engineers Australia does stipulate that engineering students must have engaged with engineering practice, which of course is work integrated learning. And now I'll move on to the next slide. I'm going to talk about 2 projects which really provided the rationale for the Virtual Work Integrated Learning project. And these 2 projects both looked at how engineering programs in Australia how students engage with engineering practice in engineering programs in Australia. The first project was on enhancing industry engagement in engineering education, and that was undertaken from 2012 to 2014. I undertook the research on this project. It was led by the Australian Council of Engineering Deans. There's a link to a site that includes the outputs from that project. It was a $450,000 project funded by the Australian government. And importantly, in that project, aside from developing guidelines on enhancing industry engagement, in order to develop those guidelines, we surveyed, interviewed, held focus groups with engineering academics, engineering employers, individual engineers who are engaged with programs with engineering education, and also students. And so we got a very clear picture of the state of work integrated learning in engineering in Australia at that time. And I'll discuss that in a moment, the main findings. Also, there was a project that I led in 2015 on gender inclusivity of engineering students' workplace experiences, funded by the Australian Government Office for Learning and Teaching, and there's a web page for that project. Now, I raised these 2 projects because they together, for me, provide the rationale for the Virtual Work Integrated Learning project. Basically, most importantly for this project, we found, can't just click on find, next slide, that the accredited programs in Australia, by and large, were addressing the accreditation requirement for engagement with practice by requiring that their students complete usually approximately 12 weeks of engineering-related employment, paid or unpaid, traditionally paid, increasingly unpaid. This was often not part of a credit-bearing unit. By that, so I'm using the word unit because that's what we use at the University of Western Australia. But I understand that elsewhere it might be called a paper or a course or a subject. The practicum in most universities around Australia was not a credit-bearing, not a unit with that contributed to points for a student to complete their degree, not a unit that students were paying fees for. It was something they did outside their units. Most often students found their own experience, and most often it was near the end of their program. I've put a little diagram at the bottom of this slide showing most engineering programs in Australia are 4 years. We have a couple of universities, including ours, the University of Western Australia, where we now have 3+2 programs. But the traditional program in Australia is 4 years, and the practicum often fits between the 3rd and 4th years. Increasingly, students are also completing their practicum part-time during the 3rd and 4th years, and some students will complete experience earlier in their program as well. But on the whole, it's fairly late in the program, in a non-credit-bearing, it's not in a credit-bearing unit. And this said, we also found very clear evidence that the practicum is often highly transformative for students. Students return much more motivated towards their studies. They develop capabilities for practice. and it helps them to understand the relevance of their program for their future work as an engineer. The assessment of the practicum at the time when we undertook the industry engagement project, 2012 to 2014, was mainly a report, maybe complemented by a logbook, and there were some universities starting to use portfolios where students demonstrated development, especially against the Stage 1 competency standards, using examples of their work and referring to some of their time while they were working. It's usually graded simply pass or fail. Now, this was the most common way that students were meeting that requirement for engagement with practice through approximately 12 weeks of engineering-related work experience. There were a few universities doing a lot more, often with many more resources and much stronger mechanisms for assessment, maybe 1 or 2 longer internships during the program. There was also at least one university not requiring any engineering-related employment and meeting the accreditation requirement for engagement with practice through engagement with practice within credit-bearing units throughout the program. So that's to give you a sense of traditional work-integrated learning in engineering in Australia. It has problems, and those 2 projects that I introduced a moment ago certainly identified these problems. They're not the only studies to identify these problems. One is that because the practicum is generally not in a credit-bearing unit, it's often not well resourced and not particularly well assessed. The experience for students is unreliable. While there are many students who have fantastic experiences, there are some who hardly interact with any professional engineers and also don't do work that is particularly close to the kind of work a graduate might do when they finish an engineering program. In fact, not necessarily engineering at all. And students are vulnerable. They can find that they are bullied or harassed or exploited in some other way, but because they must complete their practicum in order to graduate, they tend to stick it out. The diversity they experience if they only complete one period of employment with one organisation is obviously limited by whatever that experience is, limited probably to one industry, one sector, one organisation. The experience is often late in the program, as I said before. Why is this a problem? Because we know that engineering students have a very poor understanding of engineering practice, and we also know that it's important for them to feel motivated towards their studies, to have a perception of an appealing and achievable possible future self as an engineer. Engineering students often think that engineering will be largely around, well, they often choose to do engineering because they like maths and science and they expect to be doing a lot of that in the degree. They don't necessarily expect and understand that engineering is what we now call socio-technical in nature, meaning that engineering is done with other people, by people, with people, for people. And this means that there are many non-technical aspects of engineering practice that are very important, and non-technical capabilities that are important that we have in the program but often don't have much status among students and maybe not among some staff. So it's important that students early in the program gain a clear understanding of the nature of engineering practice, achievable and appealing ideas of future roles for themselves as engineers, and a decent understanding of not just the nature of engineering practice but the capabilities that it needs, so that they can make the most of the opportunities to develop those capabilities while they are in their program, not just in the 4th year of their program, and so that they feel motivated towards their studies, not just in their final year after they've done their practicum, but throughout the program. So that's the limit, why the reason the practicum is late in the degree is a problem. And very importantly, item 6 on this slide, the practicum is often difficult for students to secure, which of course leads to item 3 as well, and item 2 to some extent. Some students are even paying even $3,000 for an experience that doesn't give them much engineering-related employment. We have increasing numbers of international students. They may or may not work in Australia after they graduate, but even for domestic students, it can be very hard to secure an employment experience. So the Virtual Work Integrated Learning Project is seeking to address those problems. With the Virtual Work Integrated Learning Project, I'll just turn off the video because I was told maybe it's a good idea to show it at the start, but not to keep occupying the bandwidth later. The Virtual Work Integrated Learning Project seeks to give students the benefits of the practicum, the traditional practicum. Probably not exactly the same benefits, but the transformative benefits of learning about engineering practice, learning about the capabilities that are important, and developing capabilities for practice without a real placement. So it might complement a real placement, it might be instead of a real placement, but certainly it will mean that if we have non-placement work-integrated learning, then engineering students can have the benefits of structured work-integrated learning engagement with engineering practice from the beginning of their program through to the end, probably with opportunities to learn about engineering roles and the nature of engineering practice and the capabilities that are important early in the degree, and then opportunities for increased engagement in authentic engineering tasks and autonomy as they reach the later years of their program. Now, how do we seek to do this? Largely by using electronic means. So students will complete authentic engineering projects or tasks by accessing virtual environments that simulate engineering sites or otherwise represent engineering sites, receiving feedback from real industry-based engineers by electronic means, reflecting individually and with others. We know that work-integrated learning, we know the important features for work-integrated learning include that students reflect before, during and after the experience, reflect on their learning, and that's a really important feature of this. So students are likely in our work-integrated learning modules to electronically access real or simulated sites or equipment and or practitioners. So there might be simulated engineers in some of the early modules, but there will certainly be interaction with real engineers and more of that in the later modules, the modules for students later in their program. You can see how this addresses the problems. We have more accessibility for more students, and certainly we can provide this from first to final year. Now, I said that I was going to talk about basically the design requirements for the modules, each module being a collection of learning activities that we're designing and testing and exploring the feasibility and efficacy of. We held a planning phase in the first year of this project. It is a 3.5-year project. Originally it was a 3-year project and now a 3.5-year project. During the first year, we developed hypothetical modules, just descriptions of hypothetical modules, and we held workshops around the country with academics, students and employers, and also reference group members with expertise in work-integrated learning and engineering education, and we reviewed the feasibility and value of the hypothetical modules, and from that we refined our design requirements for the modules. One of the first design requirements for a learning module is the learning outcomes. Our learning outcomes must be aligned with the Stage 1 competency standards that are required for accredited engineering programs. We also expect that the students, through completing these non-placement work-integrated learning experiences, will develop self-directed learning. I've spoken a lot about them gaining understanding of engineering roles and the value of engineering and the motivation that should give them towards their studies. Also their sense of self-efficacy, that they can become an engineer and identity as a student engineer, so that they focus on their studies and address their studies not as something they're doing for credit points towards a degree, but something they're doing for their future as an engineer. Recognizing that many graduates might use their engineering skills to contribute to a well-functioning society in a role other than a traditional engineering role. And therefore, we expect that these modules will help students to develop ownership and responsibility for their own learning. And thirdly, we expect that these modules will support students in developing career literacy, capability to secure or create engineering work, understand the nature of the employment market, and how to develop and demonstrate the capabilities that they will need, and also recognize the need for lifelong learning, and have a network that will help them, which is one of the great benefits of the non-traditional practicum, that will help them in negotiating an engineering career, starting to negotiate an engineering career. There are other requirements of the modules that we are creating. If together we call them a suite of modules. The engineering deans were especially demanding, I guess would be the word, that these modules include realistic disruption and uncertainty. And in fact, during the project, the text about engagement with practice in the accreditation documentation from Engineers Australia has been revised slightly, and now it includes this in that documentation. The students must experience the wild nature of engineering practice. Disruption is normal, therefore disruption needs to be in our modules. And that's something that's not often experienced during a course. Now this is a concern for the students on my project, the final year research students who've worked on the Virtual Work Integrated Learning project. They were worried that the engineering students who complete the modules will think the modules are poorly designed because they include disruption. So one of the students even actually created a video of herself talking about how there was much disruption in her practicum when she did it, and therefore this is realistic and to be expected in the modules. I've talked about the structured progression from first to final year with increasing authenticity and autonomy, and the importance of these modules, including focusing very heavily on the aspects of engineering practice that are often neglected in the traditional classroom engineering education. We need to remember that engineering academics increasingly are unlikely to have recent industry experience and tend to focus very much on the engineering science elements of the program. Of course, accreditation requires that engineering education is for engineering practice, and there's a lot of effort put into this by engineering educators, but still, work integrated learning is a place where we can do a very good job of supporting students to experience the socio-technical aspects of the program, the practical aspects of the program, and financial elements. And especially to understand how the Engineers Australia Code of Ethics applies in practice, and their responsibilities around safety and how to apply those, how to meet those, and the responsibility and skills for ensuring that engineering practice is sustainable, is done in a sustainable way. Something else that is missing generally from the engineering education done at university, not through engagement with practitioners, is that we don't often use the kinds of engineering processes that are used in companies. So these work integrated learning modules do use those. I'm talking about, for example, engineering companies will have processes. This is how we do engineering design in this company. And they include even things like how we do version control, how we record minutes, simple things like that, but they include more detailed things about how design is done as well, and how engineering is practiced. The modules, we realized very quickly, initially we were assuming that these work integrated learning modules would be, we were not thinking outside the box, we were thinking of them replacing the traditional practicum, but actually we've gone way beyond that with the idea that they can be from first to final year. And beyond that, we also now recognise that they need to be possible to be integrated it needs to be possible to integrate these modules into units or papers or subjects or courses, whatever you call them, or to be standalone. And very importantly for this webinar series being on assessment, we also realised that while initially we always knew that the learning activities need to be assessed, especially that the assessment needs to be aligned with the Stage 1 competencies, but initially we were thinking we should include the assessment in the modules, and we realised through our planning forums that actually these things will be embedded in units, or if not embedded in units, they will be aligned with meeting practicum requirements for a university. And the university will already have its mechanism for assessing the practicum, which is likely to be something involving a portfolio and or logbook and or report. Similarly, the units will already have assessments in them. So we need our modules to be something that can be adapted and for which the university itself can align the module with their already existing assessment mechanisms. Now, these are the modules that we are developing. We have at item 1, the top row here, modules that are very much designed for year 1 or 2 in the program, and are modules in which the students interview and are interviewed by an engineer. This is an engineer sourced through Engineers Australia. Engineers Australia manages not only the accreditation of engineering programs but also chartered status, and engineers who have chartered status must have continuing professional development, and they can, by mentoring other engineers or engineering students, they can contribute to that. So this is a win-win, and this is around the engineering students understanding the nature of engineering practice, the capabilities that are important for engineering practice, how they will develop those during their course and keep records so that they can demonstrate them, and understanding what employers are looking for so that they recognise the importance of all of the elements of their program, and developing an identity based on an achievable and appealing future self that they can perceive because they have come into contact, albeit electronically, with a diverse range of engineers. Row 2 is modules that are more likely to be in first, second or third year, and they are around developing the socio-technical skills for the socio-technical nature of engineering practice. These modules so far are on communication and self-management, and I'll introduce one of those to you in more detail later. They are based on interviews with engineers and students who have had experience in the workplace. We've had numerous final year engineering students from across the engineering disciplines do their final year research projects on this virtual work integrated learning project, and the interviews have been conducted by some of those engineering students. Then we have modules on safety and risk. We already have some environments. There's a virtual BP refinery that was developed by universities including the University of Queensland and Curtin University in a previous project funded by the Australian Learning and Teaching Council, and we have worked with safety engineers, who I'll mention later, to develop learning modules that use the existing virtual environments to learn about how engineers can undertake processes used in industry to improve safety in engineering practice and engineering design as well. And these involve visiting the virtual site and also then interacting with real engineers electronically. Similarly, there's a module on maintainability, again using a virtual site. And there are modules on tender preparation and evaluation. These are very much the modules with the high-end autonomy and authenticity. These are likely to be for students who, these will be replacing some weeks of their practicum if they can't find a practicum. And in these modules, students either work in a team to prepare a tender or evaluate tenders. They are given their task by a senior engineer electronically. They can also interact with a more junior real engineer electronically, and they receive feedback from an engineer afterwards. They visit a virtual site which is the site where the project that they're tendering for will be happening. And there are videos that another final year research engineering student has created on the tendering process, where he videoed engineers to develop videos for students to use. And the first students to work on this project actually interviewed engineers about the important things they thought engineering students should know about tendering. And this is an example of the financial elements of engineering practice that are often neglected in engineering programs as well. So that gives you an idea of the range of modules that we're working on, and none of them are entirely complete. They're all at various stages of development and testing. We've been starting with very small, testing small elements with small numbers of students and moving to larger numbers, as you'll see. We have a simulated scenario on self-management that I'd like to share with you in a very brief way. This was developed by Courtney Elliott, but it's based on a final year student, now graduate, based on interviews conducted by previous students where they interviewed engineers and students who had completed practicum to identify engineering workplace scenarios where students need to practice self-management, and based on the things that students find especially challenging often when they do their practicum. And in this module, students make decisions in a simulated workplace, and I'll show you some pictures on the following slides. They reflect with a professional engineering mentor. So far we've tested the simulation with students, and this semester we're testing the process of reflecting with professional engineers electronically as well. And the assessment is something that would have to be integrated into the assessments existing in a unit, we would expect. So far we've been testing it on purpose-built research workshops, but eventually it would be in units. So now I'd like to show you an example of what the student sees. This has been done in a sandbox environment called ITY Studio. The interaction is all text-based. There's in this example, the student with wearing the headset is the intern, and the intern is given a task to format a tender document. They don't need to look at the content, but they discover that there's a problem. There's a mistake to do one of the costs, and I haven't captured lots of slides to show you what happens next, but they have decisions to make where they can choose what to do next. In this first instance, the intern can choose to email the company who rents the equipment to be sure about that they're right, that the quote is incorrect, or they could choose to find their supervising engineer and ask them what to do. Obviously the program goes in different ways depending on their decisions, and this is based directly on the kinds of experiences that students find themselves in on practicum. This student, if he chose to contact his supervising engineer, in the next step he would find that the supervisor is in an important meeting and he have to decide, shall I interrupt the meeting or what else shall I do? And eventually he might find his way to a graduate engineer who advises him on two more options, and eventually then he might telephone the company that provided the quote, and the immediate response he gets is, why should I help you? Which is a common response that engineering students experience in the workplace. So students would use this, they would interact in this scenario, which we've tested with a small number of students already, and then they will reflect on the experience with a real engineer, and that testing will happen this semester. Okay, now before I go into the second example, I would like to have a poll. I'd like to know whether you have experienced virtual reality. By that I mean, have you worn a headset to see a virtual environment? And there is a tick box. Mathew Hillier might step in and give some instructions if necessary. But I'm understanding that you can click yes or no. I can see.
Yeah, we've got 8 people saying yes, and we have 4 people saying no so far.
Okay.
we have ticks and crosses coming up on the participants list.
Oh, I see. Yes, 9 ticks, 10
Yep.
ticks. Yes, great.
Yeah, 10 ticks, 5 ticks, 5 crosses.
Okay. So it looks like about twice as many people have used virtual reality as haven't, but there are still some who haven't. So we found actually this was new for many of our students as well, which adds an element of excitement, but also an element of, in terms of learning activities, time spent learning how to use the equipment. But for those who haven't used it, I expect you probably have an idea about what happens. You can wear a headset and basically you feel like you are in a different place with objects in front of you that are 3-dimensional. And you really feel like you're right there. What about, if we move on to, I've got another poll, who has been using virtual reality in your teaching? Again, you should be able to click yes or no. So it looks like roughly in the other direction, twice as many haven't as have, or maybe even a higher ratio than that. 13 to 4, I think, looks like. I imagine that, I don't know if you've even considered using virtual reality, but there are many challenges, and we've tried to address at least one of those. So I'd be interested to hear comments later on from those who have used it and why others haven't. I'd like to talk with you now about a module that we have developed on teaching safety and design using virtual reality. We have used this now with 280 students in 2 units in first semester, so that's in maybe April, May of 2012. The units that we used this in were Electrical and Electronic Engineering Design Project 1 and Mechanical Engineering Design Project 1 in the Master of Professional Engineering. We based our virtual reality environment on a case that is a real example of a case that has been involved in fatalities. The example is a crane on the back of a truck. We worked with Safe Work Australia following a workshop at the Australasian Association for Engineering Education conference a couple of years ago, where I made the contact with Safe Work Australia, and where in fact the people who ran the workshop used the same example as we ended up using. Safe Work Australia put us in touch with regulatory authorities in Queensland and South Australia, who provided us with many examples of engineering equipment that had been involved in either fatalities or serious injuries. And we worked with safety engineers, Mike Hurd and Mike Dean, who I've named here because I'd like to acknowledge them, on how, what are the important things that engineering students should know about safety and design. And their important message was that it should be something that is a continuing process throughout the whole design. And we decided to use as an example of an engineering process CHAIR, which stands for Construction Hazard Analysis Implementation Review. It's basically a kind of workshop where engineers and other stakeholders would identify hazards in it and how they might remediate those and improve the design or otherwise address the existing design. And we, Patrick Kenworthy, who was a final year mechanical engineering student, developed a VR, a virtual reality environment where the student, when they put on the headset, they are standing beside a truck, a crane on a truck, and with the handpiece they can operate the crane to move a piece of equipment from the truck onto the ground or vice versa. And it has flaws which are real flaws in the real design that contributed to the fatalities, most likely. So students completed this activity and completed a CHAIR template in which they identify risks and ways to address those before they used the virtual reality, after they used the virtual reality, and then again after they reflected as a team with an industry-based supervisor there with them as well. In terms of what I was interested to find out whether people have used VR, because one of the big hurdles is engineering classes are often very large, often much larger than ours, sometimes even in the thousands doing one unit. How do you use this with a large cohort? I visited the University of Sydney, has a room where maybe I think it was about 24 students could use a VR headset, not with a handpiece, but a VR headset at least. But even then, how do you get thousands of students through? So we tried to address this problem, and our solution was the students were already in groups of about 6 students, and we set things up so that one student in each group wore the headset and interacted with the handpiece with the VR environment. The others observed, and they could see on a screen what that student was seeing through their headset, as well as watching the student using the headset and trying to operate the crane. And of course they could talk with the student who was using it, and they discussed it afterwards. We got the students to actually use different colours when they completed the template at the different stages, so we could see how the hazards they identified changed throughout the process as well. So here's a photo of the students. We actually had 3 teams in a room at the same time, and one person in each team was using the virtual reality. And for each unit, we took a few days at least of occupying this room in 1 week to get through all of the groups in their normal scheduled classes. You can see on the screen the students looking at what the student wearing the headset can see through the headset. And the interaction is, these students are actually already have as their facilitators or supervisors industry-based people. So we have that interaction built in. This is just showing you the other part of the room, so you can see there are 3 sets going at once. Now, you'll remember at the start I talked about how the assessment can't be actually fixed in the module. We need to fit it in with the assessment in the unit, and this is to show you an example of this. In the electrical design project unit, ELEC 5551, we have assessment of project management. These are team projects, and there's a very clear principle based on a previous Australian project on assessing individual learning and group projects in engineering, that assessing the project outputs, the team project outputs, is no way to assess the individual capabilities. So you need to also assess individuals and effectively also their processes throughout the design. So we have here assessment of the project management for whoever the student is who's rostered on project management for a particular period, in this case for the 2 weeks when the students undertook the VR activity. One student would have been the project manager. That student would have been assessed based on these items using this rubric by their industry-based assessor, the engineer with who comes from industry. Similarly, all of the other students in the team would have been assessed based on these elements. Obviously, the notebook is not part of what happens in the meeting, but they should write things in their notebook about what happened in the chair meeting, in the meeting using the authentic engineering process. And by the way, this is authentic not just in that the engineering process is one used in industry, but also because virtual reality is now starting to be used in the design process in engineering as well. Similarly, in the design unit, the mechanical engineering design unit, those students have formative assessment as well. They are expected to do preparation every week, and they have to rate their own preparation using a marking rubric, and then the industry-based supervisor checks their self-ratings. And so when we implemented the module in this unit, the students prepared beforehand. They were asked to read about chair beforehand and apply it to a different case, and they had to rate their own marking of that, their own preparation, and that was assessed, that was checked by the industry supervisor during the module. So again, we linked it to the existing assessment in the unit. And I also linked it in the electrical and electronic engineering design project unit, which I coordinate. I linked it to the final report by including this element, which should be there anyway, that students should have in their final report the safety issues that they identified, the processes that they used, and the mitigations. So that gives them a chance to use the process, the chair process that they learned about in the module. So linking it to assessment is absolutely critical, otherwise they wouldn't even turn up. And we did find that, we tried to address this problem of how do we put students into, from large cohorts in using VR. And the idea of having some students use the headset while others observed does seem to have worked. We found, I've got the participants here, but I'm running out of time, so I won't go into detail about those. But we did find that when we asked the students how strongly they agreed with the statement that by wearing the headset or watching another student wearing the headset, they believed they identified a safety hazard they'd not before identified. You can see that we have a similar and high response, strong agreement, almost strong agreement on average for both the students who were watching another wearing the headset and those wearing the headset. This is for the electrical unit. The mechanical unit we've analysed separately because we did improve things slightly and they had the preparation. In fact, we reversed the result slightly. I'm not sure whether that's significant, the difference there. I'm more interested in the fact that all of them are high. In particular, the students not wearing a headset reported that they also identified hazards that they hadn't before identified after watching someone use the headset, which shows us that we have a way that makes using VR in large classes more feasible. I'll conclude there. There are numerous opportunities for non-placement work integrated learning in engineering. They have the benefits. We certainly are seeing the benefits that we were hoping to achieve. And this project, as well as developing modules that can be used or adapted by others, is certainly testing the feasibility and efficacy of non-placement work integrated learning, taking advantage of electronic access to sites and or practitioners. We have one more year for the project to run and we have a lot more testing and importantly opportunity to establish a sustainable implementation during that time. And I think that the engagement of practitioners through Engineers Australia is an invaluable component of this project. I think also this idea of making sure that assessment, that learning resources are adaptable for the assessments that people already have in their courses is important. Before I conclude, I would like to acknowledge in particular Courtney Elliott and Patrick Kenworthy, who developed the modules that I've shown you, and the other people named here have been supervising those, either the module development or the implementation. I'd also like to acknowledge the student participants and the professional engineering participants who have helped us evaluate and develop modules, and the other virtual work integrated learning team members related to other modules that I haven't spoken about in detail but did outline earlier. And these are the sources of support for our project. Matthew, I think I'll hand back to you.
Sally, thank you very much. So folks, if you have any questions, now's a great time to ask. Bung them in the text chat box, or you may want to use your microphone. If you do, just use your hands up symbol. There's a question from Peter down in the text chat. Sally, if you'd like to address that one.
Yes. This is an interesting one. The employers are very keen. They, when we interview them about the tendering and when we interview them about the, ask them to create videos for us on tendering and so on, they're very keen. The students more are concerned that employers won't like to hear that somebody has been doing virtual work integrated learning, because it doesn't sound like it will be very real and helpful, really. So this is a valid question, and even goes for us towards wondering whether we should rename some of this, and whether they actually end up employing people and being just as happy employing people who've done virtual work integrated learning remains to be seen. Certainly, I think it's also worth remembering that we don't aim to exactly replace. That would be not the goal. The goal is to complement real placements and especially provide the benefits that I've spoken about, which are not provided by real placements generally. I hope that answers the question. Okay.
Yes, it's interesting that I'm not sure, it was somebody from a senior government education minister, either in New South Wales or the federal, sort of complaining that people doing online teaching degrees are not equipped to do real teaching. So there is this, I suppose, a perception issue there around the quality or the adequacy of an online education program. I mean, it's interesting. You're not advocating removing, real work integrated learning. But this is a fantastic opportunity for giving people a richer range of experiences, and I suppose I see it as a gentle on-ramp, if you will. So you might do a small virtual activity before you go off to do the real thing.
Absolutely.
So I think there's an awful lot of boundary expanding capability of this kind of technology. Tristan's got a question or a comment down the bottom you might like to address too.
I like the way VR can allow students the opportunity to experience risky situations. Exactly, yes. Allows the opportunity to experience fail. Yes. Yes, so this is one of the benefits as well, that with an immersive environment that students can interact in, they can set up their own experiment effectively. For years now, people have been looking at online labs, and some people have been arguing they're not the same as a real lab. Well, they're not, but they do give a student the opportunity to set up their own experiment and keep trying different parameters and so on. And the same goes here. Students can do things without, especially our crane on a truck. Site visits with thousands of students or even hundreds of students are pretty much not feasible. And even if it were feasible with the numbers of students, it's not something we would ever do, something that lets a student experience something, operating something for which they would normally need some kind of training, and which is dangerous anyway. So yeah, there are lots of opportunities. It is a nice opportunity for us to use virtual reality in teaching. Different from the usual clinical simulation, absolutely. I think this idea of disruption and autonomy is a really important element for us to maintain. More task-oriented, yes. Oh, thank you. So I'm reading the notes, Matthew. Is that right?
Yes, you're welcome. Yeah, of course, that's what we're there for. Scott from Monash himself runs a virtual Chinese. Scott Grant from Monash is a colleague of mine. He runs a virtual Chinese city island where he has students go in and do task-based language learning activities. A lot cheaper than sending them to China on an aeroplane. Not saying that going to China is a bad idea. It's a very good idea for a language learner, but it's a lot cheaper to send early stage students into a virtual space. Let them make mistakes, let them gain confidence before they go into the workplace. And that also applies to, dangerous environments, medical, engineering, mining. There are so many things that we wouldn't dare send our students into, but a virtual environment helps them prepare. So, I just see it's all positives from what I can see of it.
Yeah, I'm seeing someone saying that Susie Schofield in Dundee is using it in medical education. Because of the previous comments, because of risky situations. Yes, absolutely. In fact, I think there's probably a lot more money has gone into developing very good VR in medical applications. We are hoping to access some local companies using virtual reality for training for mining companies and so on, and they've offered to make some of that available to us, which would be great. And also interaction with overseas would be something really exciting to have an opportunity. I haven't investigated that, but that would be really exciting.
Peter Law has got the comment. What was the motivation for the VR approach to bridge skills gap? Or due to the difficulty in getting placements? I mean, you did sort of talk a little bit about that earlier.
Yeah, a bit of both. Probably, the first rationale was certainly the issue of difficulty finding placements. Especially when numbers, we had I don't know if people elsewhere are aware of the circumstances. When we started the industry engagement project, it was initially to enhance industry engagement, to meet the numbers of graduates that were needed to graduate the numbers of and provide the quality of graduates needed for the mining industry. By the end of that project, the mining industry had disappeared all but. And so it was more about how do we find placements at all for all these students. And so that led to the obvious question for me, there must be a better way of doing this, or a more reliable way of doing this, especially in the boom-bust cycle.
Yep, sure. Chris Landolf has also got a comment down there. Do you think something like 4D photographic surveys of construction sites over time can be utilised as an alternative to VR? My quick answer would be horses for courses. Sorry.
Chris Landolf has developed a fantastic 4D environment of the Equinox Manufacturing Building at the University of Queensland, and we're doing that at UWA and hoping to put it on Chris's site. So absolutely, I see a lot of opportunity there.
Yes, we had a webinar on that project as well. So if you look through our past events, you'll find a webinar on that too.
I think I might have watched that.
Yeah.
I think that was partly what gave me the idea.
Somebody's asked, I would like to use VR, virtual reality. Where can VR be found? Is there any specified organisation creating it?
Yes.
Multiple.
Yes. I can tell you that the easy way in for the students, it was not that easy. It does take an engineering student, it's quite a steep learning curve, but our engineering students have been using Unity, which is a gaming platform. It's got a free license. It was HTC Vive that we used, but there seemed to be a lot of help online for them. They're looking up things all the time and getting advice from other people on how to do things. And there are lots of, they actually purchase a lot of the models that they use. They don't have to create it all from scratch. I'm sure others are more aware of other networks. Probably the students could have answered that better than me. And my projects are co-supervised. The ones where students develop VR, I actually normally have a co-supervisor in computer science. I'm based in electrical engineering. Thank you, Teresa.
Peter also said, I've been looking at digital literacy. Is there such thing as a VR literacy?
Yes. Now that's that is an important question. One of the things we improved going from the first, we used the VR in electrical engineering first and then in mechanical engineering in those workshops. And one of the things that we improved going from electrical to mechanical, but from the first unit to the second, was we reduced the learning to use VR time in the learning activity. And we did that by actually removing some elements of the freedom for the student. And that is a topic that's in the literature, how to reduce the barriers to use. And there's another term they use for basically getting used to using the VR so you can get on with the learning activity. So in the first version, we had the student able to teleport around the truck, and we removed that. The student was fixed beside the truck. Otherwise, they would accidentally keep teleporting into the places that were silly, like into the control buttons or something like that. We also improved the boundaries so that it wouldn't allow students to go where it wasn't sensible to go, and we made it reset if anything silly happened, whereas before we had to come along and manually reset it. And we also gave the student in the VR environment, they were given a clipboard that had instructions so that they didn't have to be told the instructions or take the headset off to remember what the instructions were about what they had to do. And also instructions on how the buttons worked for the control system. So just simple things like that to try and make it so that the entry to use of VR was simplified. It's a really important question. I've got another student looking at the level of authenticity or fidelity in the virtual reality and the extent to which that enhances the engagement or distracts from the learning, which is another topic in itself that other people are studying as well.
Yeah, I think there was some work in medical field around the fidelity levels of simulations. It doesn't have to be, photorealism or something.
No.
Even sort of cartoon-like environments can work because it's about the key learning that's going on. It's not about how, whether it's really real, there's the element of people suspended disbelief. The fact that you can understand that it's a simulation and go along with it.
That's
not
right.
expect that it's going to be, it's authentic activity. It doesn't have to be an entirely authentic, photorealistic world.
Yeah. That's right.
Yeah. Okay, we are over time, so thank you very much, folks, for coming. I'm sure Sally will be happy to answer more questions via email if you would like to do so. I'm assuming, Sally, you are quite willing to accept questions.
Yes.
But thanks for the interesting session. There's always interesting things going on in Australian higher ed, I find. Technology is definitely expanding our boundaries. So thanks very much, folks. We will be taking a bit of a hiatus next month, but we'll be back in, where are we, September, October, November for a final session on, assuming that that goes ahead, it should do, mindfulness in assessment design. So thank you very much, and we'll see you shortly. And Sally, I believe you'll be coming to our e-exams session in Perth on Monday.
Yes, I will.
Yeah,
Thank
great.
you for the opportunity, Matthew.
No worries. See you on Monday, Sally. Bye all.
Bye-bye.